So appreciate everyone coming out. Following after lunch is probably only second worst to being before beer 30, so hopefully we can make DevOps exciting. Some of you may be confused, so don't run away. DevOps, this is Cisco. Cisco is surprisingly a software company, transforming every day into doing a lot more cloud-related and not just the routers and switches you may have always thought of Cisco as. So hopefully you're in the right place, or you're going to learn something about what Cisco's doing. Going to be a lot of DevOps concepts. This is kind of an intermediate session, so I'm going to go through some slides, and we're going to get to some demos. Hopefully, I'm going to go through a few things quickly. So hopefully some of you have an understanding of DevOps and some of the concepts I'm talking about, so I don't leave you behind a bit. So what can you expect? We're going to talk about why we need to automate. What really are we trying to accomplish? A lot of DevOps has been tool-based and workflow-oriented, and it's starting to move to a lot of model-based approaches, where you're capturing a model that's declarative and then asking something to do what you intend it to do and not really always understanding what needs to be done under the covers to make it happen. So that's what I mean by a model-based approach. As you start using a lot of places, we get into the concept of image management and having to have your right approved images in all these different places. And we have a lot of other features when we're talking about an application-centric kind of world, because a lot of times your end users, your line of businesses, they don't want a virtual machine or a virtual NIC. They want an outcome, a business outcome. Usually that's an application. So what does it look like to deploy an application without automation? This is actually kind of some info taken from one of our customers, financial services customer. They have, before they really got into automation, they had 127 steps in a manual process. Likely some of you can relate, moves through tickets. 5 different silos of teams that fulfilled the 127 steps in their various forms. Typically took them about 3 weeks to do that process. In the end, they didn't always have the final outcome that they wanted. So what happened? Sometimes it had to jump back into the process. So what does that mean when we start automating certain portions of it? Well, a lot of times in the automation, we have wait times. Moving the ticket between teams is time that passes, but it's not actually being worked. So the blue represents where nothing's occurring. You're waiting on gear, you're waiting for a rack and stack, you're waiting for power, you're waiting for the guy to come back from vacation who knows how to set up the DNS or the firewall. There's lots of things and people involved, and it's complicated. It's getting more complicated, actually, because we have a lot of loosely connected systems that run in lots of places, whereas we used to know where our things ran. We could define them very well, and the control and governance was actually these steps. Agility is kind of in conflict with control somewhat. So how do we have agility with automation and also bring guardrails to it to have the governance and controls we need? How do we get rid of some of these blue times that really aren't providing the value and the outcome as fast as could happen? So if we just do VM automation, we're taking out some of the steps. We're delivering a virtual machine, but again, I mentioned an outcome. There's still network guys, security guys, application guys, testing, et cetera, that aren't occurring. If we keep adding more, let's get into network automation with software-defined networking. We're removing more of the steps. If we get into a full application orchestration and infrastructure automation, we still don't quite have the guaranteed outcome, but we're getting really close. We're down to, a handful of days. We're left with some things like, how do I always get the latest code? How do I have external interfaces? And then finally, how do I actually have testing and quality assurance to say, this should go to production? And so let me ask you a question. How many of you guys are actually doing a lot of automation and DevOps today? Just show of hands. Pretty good group. Now, a lot of times, there's a lot of technical ways to do this, but there's some things that are missing from it. You have an on-premise environment today. You're trying to use a lot of this automation, and maybe it's wired to what you do today in your on-premise environment. How do you take that automation you may have and actually start consuming Amazon services, for example, if it's new to you? So why do we sometimes need to move off on-premises environments? Capacity limitations. We have customers. I heard one customer, the power company flat out can't bring more power down the road to them. It's not an option to put in more racks and servers. They are out of utility space. Other customers, you just don't want to be in the data center business anymore. It's not a core competency. Maybe you want to focus more on your business, your core differentiators, and let someone else do the things under the covers that are important. A lot of people are starting to move to pay for what you use. People have been going around IT somewhat because they could quickly swipe a credit card and pay for what they use, and they didn't have to have a big time investment, and it was a lot cheaper to get what they wanted. Self-manage. If your IT organization isn't as innovative as you are as a DevOps team, you want to manage your environment, and moving out of the on-premise environment may be the only way you can do that. We're finding a lot of these new applications, social, mobile, analytics, cloud applications, they run best some portions at the edge. Mobility apps, content distribution networks, those are out at the edge. Those are where the mobile devices are. Having it all come back to your one central database on one coast may not be performant when you all of a sudden have 5 million mobile devices connecting to your application. It's ready for you. Amazon, they do a great job. They have services that are always there. Sometimes if you need to add more capacity, how long does it take for it to be ready, even for your highly automated processes? I think Amazon has a few others on their website, converting capital to variable, stop guessing at capacity, increase speed and agility. They have another one in their website, go global in minutes. You guys may have a lot of great on-premise environments, but all of a sudden you need to have a global presence. How do you do that? A lot of you don't want to build data centers. So good reasons to move out of on-premise environments. Migrate back. Do you need to come back sometimes? Yeah, sometimes. Scale up multi-use databases. Maybe the center of the world is one big scale-up Oracle rack or some other system that your business has been built around. You may be out innovating some of those other platforms, so you have to come back somewhat. Interact with other applications that aren't externally reachable. We still have security officers and organizations that are concerned about the security of the cloud. That's a whole other topic, but it may be the reality in your organization that some things have to remain back, not publicly accessible. And if they're federal customers, secret classified networks, a lot of the utilities have requirements, SCADA networks, they're disconnected. So you have applications that benefit from the DevOps and automation and cloud world, but still need to live somewhere else. Compliance. Arguably, Amazon has a lot of compliance capabilities. If you're a PCI or a HIPAA, there's ways to say that you can be PCI compliant, but maybe in your organization that's not recognized as acceptable. Here's an interesting one. What do I mean by free resources? You don't pay for it. Sometimes what you have on premise, it's there, it's someone paid for it, it's underutilized, and for you it's free. There's something to be said for using a capacity that's going unused for free. So I mentioned a model-based approach. I'm going to mention an application profile here because we're talking about things becoming model-based. And so just candidly, I came to Cisco from a company called Clicker that was acquired a while ago. We have a product, so a lot of the semantics here and some of what we're going to show is integrating DevOps into what Cisco can do for you. So I want to kind of get some of our graphics and icons into the conversation so when you actually start seeing later, it will make sense. An application profile really is capturing all your tribal knowledge. So DevOps has a little bit of a challenge in adoption because it's not just a technical thing. There's a people process aspect to it as well. And so some of you who raised your hand and said you're great in DevOps, you may have a lot of awesome stuff that's occurring, but you might have a corporate security officer who's a little concerned that he doesn't quite have the safeguards around it that he wants. And so the application profile has kind of these components to it. It's a lot of times now a graphical topology model. You can kind of slide some things. Do I need 2 CPUs or 4? Do I need a lot of memory, a little bit of memory? The profile doesn't really care. These are kind of deploy time kind of concepts. It can be mixed use in our product. It can be containers. It can contain recipes. It can hook out to other things. It's Java applications. It's binaries. So the actual application outcome is what's captured in the application profile, not just an infrastructure blueprint, not just spinning up a virtual machine. And finally, another one didn't come up. All right. So you got the cube. So what's in the cube? The build process, the packages, the files, the scripts, your data, the environment. Eventually it has to go down onto an environment. You need images, you need services, you have containers potentially coming into your environment. We're even getting into stateless, serverless things. You're probably hearing a lot about Lambda, stateless C# kind of things. So we're getting where there's not even a virtual machine or a container. How do you kind of direct those things and then get your application onto it? A lot of times there's still, the networking is complicated. Who can talk to who and why? The cloud services that fulfill extra things, firewalls, load balancers, extra services, et cetera, are all kind of captured in an application profile ideally. So for those of you that raised your hand for DevOps as well, a lot of times what we're talking about is the build automation may be very mature. DevOps has typically been led by developers, application teams. Once they got what they needed from IT, it was maybe just an infrastructure IaaS product. They then had to go tool up their stack and do what they did. And so a lot of that DevOps culture has come from these guys who know how to kind of build it. And so that process is very mature. Getting it built, getting code checked in, and having it go to a repository to be consumed. Now, For the developers in the crowd, your job is to write code and deliver outcomes in sprints if you're an agile shop. Tooling up stacks and learning infrastructure in one may not be your familiarity, may not be your job, and it may be a distraction. And so as we kind of talk about the deployment automation being added to build automation, that's what's really not as mature in a lot of organizations. What can I deploy where, and does it have the right things my organization wants? So we take this to an application and kind of start scaling it out. You can have a very good process that's script-oriented, but as you start to scale it, you're maintaining scripts, start to end, they're very complicated. You have an application using one Amazon region, for example. It's hardwired. When you have to add another region, okay, you can clone it, duplicate it. You're now maintaining 2 code paths. Not too bad. But what happens when it starts scaling out? Version 2 of the application. The other dev team likes what you do. All of a sudden, they started creating it. This can very quickly kind of get out of control. How do you manage the sprawl of the back-end processes? So you just created another thing you have to manage, which can become very difficult. So hardwired automation is difficult to scale. And this is kind of what it ends up looking like. Some of you may not be comfortable with this kind of build. This is actually a very condensed version of it where I'm variabilizing a lot of things like subnets, security groups, instances, keys, instance types, but it's hardwired as well. We have some customers, I think this one's 142 lines of code. It has 1 load balancer, 1 web server, 5 security rules, no app configuration though. All I'm doing is spinning up a virtual machine with all that. This assumes that you have regions set up, images, users, IP blocks, and these have to be known to the person who's configuring it, which may not be you're in your wheelhouse. To really get this fully automated, like my first kind of drawing that made it end-to-end and collapsed the 127 steps down into something that was a quick outcome, you need to know all this stuff and have it built in. We have a media customer that had this kind of environment. They had on typically about 1,200 lines of code for their deployment process that included end-to-end applications. They told us that when they made a change, new region, new place, on-premise versus AWS, that it was about 20 to 50% of the code actually had to change underneath. And that was really the hardwired stuff. Their application, their outcome didn't change, but how they got it to where they needed to go was a significant effort. And as they scaled that out to applications, it became really hard to manage. So, this is an example of kind of how you do it in one product. A lot of times AWS credentials are hard-coded in this kind of environment, which can be challenging. There's actually people out there who are mining GitHub, going in, looking for AWS keys, and what are they doing with that kind of stuff? They might come and steal your console, hold you hostage. They might go mine Bitcoins on your dime. We see that a lot. So a lot of times there's security implications of having this hardwired automation. This CloudBees, there's a lot of great products that do this. You may own some of them. Just picked on this one. It's a good product, one of many. It's doing all this. There's lots of scripts that are occurring. Every task has to be coded by someone, then version controlled, and the scale and parallelness of it kind of is where you get out of control. So really, as a Cisco product that we're going to kind of use in some of these demos, this is kind of where Cloud Center comes in. How do you decide where things should go, the governance, the controls, the guardrails around it, getting rid of some of the cloud accounts, the API keys not being embedded, who can spend what, where, et cetera. So you'll see the product a bit in the demo, so I want to set up kind of what you're seeing since it may be new to some of you. So it's cloud management brokerage platform, application profile model once deploy anywhere. Anywhere in this case, because this is Amazon, could be lots of regions. We'll leave it at that. I mentioned guardrails. So this is really important. DevOps and automation is great. We want to provide, is it the right place at the right time? Is it the right person? Who's the spend? DevOps has a concept also of fix it forward. A lot of times in traditional IT, we're talking about rolling it back. Automation also tends to amplify behaviors. Are you amplifying a good behavior or a bad behavior? By breaking it down into an application profile, we start to segregate the ownership of the best practices. You'll see a concept of a service as well. A service is a Lego block. So let's just say your F5 person wants to imbue the best practices of that load balancer F5 Lego block that then everyone else can consume without actually knowing how an F5 load balancer works. So the services are also a model once, kind of reuse over and over, and we'll talk later about how we use those. Multi-tenant, multi-account, and also benchmarking. Where's the best place to run my application? If I have a way to have one kind of managed entity that I can then deploy lots of places, lots of different sizes, without having to manually kind of tweak it, then I have the ability now to actually deploy it lots of places and run application performance against it. Should it be a medium or a large? Should I run 4 or 1? Does it run better in my on-premise environment, or does it run better out in region 1 or region 2? So, distributed architecture, profiles pass. We're going to go through this quick because we want to get to the meat of why you guys are here. So, what's one of the first challenges when you start talking about deploying to lots of regions or a mix of Amazon and your on-premise environments? You need images. And so a lot of times in DevOps, when we're talking to the actual dev teams, one of the first things that comes up as a conflict in the organization is, well, the security guys want it to be based on the Red Hat image, the Windows image, the one that's blessed, that has all the right controls, that we know is getting patched and maintained. And this kind of gets into some of the DevOps concepts, pets versus cattle. Is it long-running or short-lived? You know, really both are applicable to an application profile model-based approach. There's a little bit of differences of how you maybe patch them in place. But the concept of where does the master image come from that is used. And also, you have different image formats now. It was really easy when you had maybe 2 data centers on-premise. They were all the same virtual disk format. Your team that built disk images could build them, push them to 2 places. Everyone could easily consume them. It's getting hard to do that now. So you have multiple virtualization formats. There's storage costs, you know, for example. So you don't want to have a bunch of images around because you may have the concept of thin provisioning on-premise. That isn't necessarily what is available in the public. But you can also argue that the public cost per gig is a lot less expensive. Region-specific requirement. Images have to be localized. If you want to deploy an application stack in Amazon US East, you have to have the image already there. And if you want to deploy it in Tokyo or as a new region comes up, like the UK or some Ohio just came up online, you have to get your images there as well. So to consume the growth of Amazon's regions or the growth of your on-premise environment, you have to get these applications and images localized. Any of you from Europe, Germany, data has to stay in Germany. So example, how do you get your images and applications in Germany so they run and stay in Germany? These are real kind of ops problems that your DevOps guy may have figured out a really good way to do it, but now you kind of have to get these other concepts taken care of. The pace of patching is increasing tremendously. I mean, any of you guys who are operations in the background, just operating system patches keep going. We now have a lot more systems and gateways and APIs, and a lot more open source applications are being used. It's great, but you got to stay on top of the patching to keep your organization from not being vulnerable. In some cases, you're imbuing those patches into your image process. So I'm kind of getting to something. How many of you guys generate your images basically from scratch every month? Packer, Vagrant, anybody? A few? Okay, so this first demo is actually showing that. A lot of times traditionally, since there was a lot of people who aren't doing that, what's happening in your environment probably is you have a virtual machine image. It's opened up every month and patched in place, closed back up, and people reconsume it. So as you actually start having applications embedded into the images, well, one, you have images. Well, I have an image with Microsoft SQL already built in. I have an image with Oracle already built in. You don't have kind of ideally, if you're an enterprise and you use Windows and Red Hat, it'd be great if you could just have a Windows and a Red Hat lowest common denominator image, and everything just kind of builds on top of that. Now, or sometimes, let's use Netflix, for example. They have a service, they need to scale it out. All of a sudden, a really great, what was it? I think Michael Jackson passed away, and all of a sudden, just unexpectedly, that was a huge thing for people going into Netflix and looking at what was going on with his career in images and videos and such. So that was all of a sudden a capacity. Well, they have a single service, so they have everything already built in because they want to fire them up really, really fast. So there is times when you want to have applications baked in already, the image is really self-contained and ready to go, and you just want to quickly get it provisioned around. So there's a place for that, bake versus fry is the DevOps term. But ideally you want less images to manage because now you also need to get them in lots of formats and lots of different places. So there's a balance here of speed of getting something turned up, like Netflix needs them fast as viewers start streaming, versus your security guy who really like to only bless 2 patching and image management processes every month. So that's the balance. So we have some options. We can transform these gold images you already have. There's ways to kind of transform them, which means I've got them building in one place. I then use some sort of bit flying image transformation process. A lot of you, there's a new announcement from Amazon and VMware together where VMware ESXi can now run Amazon, and there's a process for a tool that will actually convert them from VMDK to the AWS AMI format. So that's an example of transforming your gold images. Rebuild images dynamically. This is what we're going to kind of demo today, where every month you can actually rebuild based on your best practices are scripted, and you rebuild them dynamically every month, and very quickly you have the images positioned to all the places you need them, and they're rebuilt using the reproducible process every month. That's really the DevOps way to do it. That's fix it forward. If you need an OS improved, rebuild the image. Rebuild then all the applications on top of it. This is a hard concept, though. A lot of you have long-running applications, legacy applications. How many of you guys have the one server in the corner that no one will touch, and the guy who ran it left 5 years ago? When I say rebuild images and redeploy your application, that snowflake scares the hell out of you, doesn't it? So, there's ways to deal with that. You can always physical to virtual, convert that and make that redeployable in the images process. So there's a lot going on in your organization that has exceptions. There's also a new trend that's happening here. The vendors are actually providing patched images in marketplaces. Red Hat, Microsoft, you can go to the Amazon Marketplace and every month pull down the latest CentOS, Red Hat, Ubuntu, whatever your preference is, and every month they're actually doing all the kind of core OS patching and maintenance, and then all you have to do is take that, consume it, and load in what you want special. Your security guy may want a couple things turned on. You may have a habit of turning on all the services until they're actually used, things that harden it further for you, but you're starting with a really good source that's patched very regularly, and someone else is doing the work for you. So that's the benefit of these image marketplaces, is the OS vendors are actually taking on a lot of the responsibility of the patching. So we're going to jump around now a little bit between demos and screens, so bear with me. Hopefully this is fairly seamless and works. Let's give it a try. How about that? I cheated. I did videos. I don't want to be Bill Gates with a blue screen up here on stage. So I'm going to talk about quickly kind of what we have as an application profile. This is the catalog that we have. So I'm going to show you real quick before we get into image management, this is an application profile. I'm going into it as an editor, and you see it's graphical topology. I mentioned the model-based approach. On the left are the Lego blocks that can be dragged and dropped over. So we have things like load balancers, databases. If you just want a VM, it's just a virtual machine, and later you can just get into it and tool it up yourself and turn it into later something. In the DevOps, I said build automation is very mature. So what we're going to start here with is this is Pet Clinic. There's an application Pet Clinic here. It's pulling from a well-known, trusted repository. We're going to go into Jenkins. A developer's life is going in, looking at a project. So here's a project that's kind of set up. We've got that it's going to build and deploy to Artifactory, which is a type of repository, Git, SVN, et cetera, or others you may use. So this is setting up the Jenkins projects. The dev team lead typically sets this up, and then his dev team working on it consumes code, okay? So when I come in and configure now the project, we have a plugin, for example. There's lots of people that provide plugins for these. So this is stuff that's being pulled now via APIs from our product. Where should it go? Governance-based tags. Dev should go to a certain region, attached to a certain network. Or maybe dev should always come private. Or maybe dev always goes to Amazon because you want the more ephemeral, transient workloads there, and you feel more comfortable long-running production workloads private on-premise. That's your choice, but governance-based tagging is what supports that. So in the middle there it says deployment environment dev, that's kind of what's being shown. Cloud type, what clouds does this person have access to? So that kind of model once deploy anywhere starts to introduce the concept of regions, which on-premise environments, et cetera, and what kind of instance types, et cetera. So we're going to come in now. A developer would now come in. I'm getting ahead of the video here. Okay, so here's what he's got an artifact. He checks out his code. He's going to come in and make a change here. Welcome to, instead of Mo Magic. If you guys go to the Cisco booth, Mo, this is Mo's video. Tell Mo hi. Mo thought he was funny. So reInvent 2016. I'm changing my code and checking it in. So in a build process, what now happens is code's committed, the build tools pick it up, and start actually building it. And developers in an agile environment want to see their code be tested. If it fails, they're responsible for going back and fixing it right then and there. When it's successful, what happens here now is you see a build success is now occurring. On build success, what does a developer usually want after he builds his code? Well, ideally, he wants to put it out on the environment and actually do further testing, load balancing, stateless versus stateful, at scale, regression testing, things that he actually needs the stack for. This is the kind of stuff a lot of times developers used to have to kind of tool up. Now, how many of you guys are in operations and more traditional IT versus dev? Okay, so this is the part that usually scares you. How many of you have been up Friday night, 2 a.m., Saturday night, 2 a.m., it worked in stage, and it doesn't work going to prod. Well, here's an example. The devs tooled up their stack, and it's not necessarily their fault. One, they may not even have knowledge of things like production firewall configurations. They tested it in a lab where there was really no blocking or anything, or they didn't have access to a load balancer, so now when it goes to production, you introduce these variations. In a model-based approach, you're incrementally kind of improving the process, and they're deploying in dev the same things basically the way it would be deployed in prod. And that's how you kind of get that fix it forward and creating the safety net when it finally goes to prod. You know it works. It's already been deployed 1,000 times, and the profile and process kept improving iteratively over time. So when it finally goes to prod, you trust that it goes there. And that's how people like Intuit and others that are these big DevOps poster childs, they have these processes, they're iterating and they're building often, and they're actually doing it the same way in dev that they would do it in prod. So finally what happens here is it jumps out and the build says success. Jump ahead here a little bit. And then you end up kind of in our product. So the build process now called the tool that helped with the deployment automation. This is a lot of times what's missing in the dev teams. They don't have the deployment automation that actually helps them get onto the infrastructure, request VMs, et cetera. So now you actually see a stack that's being deployed. This was deployed in Amazon, C3 larges, attached to the right network. These are things a lot of times devs don't know. What VPC should dev be attached to? Which subnet should I use? This is kind of all part of the application profile and model-based approach. And ultimately, they're getting the result they need. The application's deployed, they have access to it, they can remote onto it, they see the IP addresses. This is going to actually give them a link, and you're going to see a pet clinic application here in a second that's deployed. And now they actually see their application and they can do what they want to do. They didn't have to wait that 127 steps, 5 teams, 3 weeks, all that blue time that really wasn't productive. That's what's gone from this process. Dev checked out code, dev committed code, dev built successfully, dev got it in a working website. He could actually go kind of see his result and didn't really have to be slowed down by other processes. All right. So, I got to remember a clicker here now. All right, so let's talk a little bit about networking. Networking is probably the hardest thing. Coming from Cisco, obviously we have a perspective on this. You're simplifying the complex through APIs. Amazon has done a great job creating layers of configurations to give you networking controls via APIs that are very flexible. Cisco has something called Application-Centric Infrastructure, ACI now, which is a programmable fabric on the private. So a lot of the same concepts are being introduced. Any of you Cisco customers, thank you, great. If you have your competing product, they likely have innovations in this area too. But there's a few things about networking you need to know. One, AWS networking is a little different. Consistent implementation between on-premise and public, Amazon, is a lot of times what we hear. How do I get it to be the same kind of isolation methods that I accept in my on-premise environment, and now I want that to be laid out into the Amazon zones. Availability zones, fault domains, let's call them. To get your uptime guarantee with AWS regions, you actually have to consume across multiple availability zones, and so that adds a little more complication into the placement and getting it there so the application is actually scaling horizontally. There's also different practices. Any of you who grew up programming firewalls, using security groups and access control lists is a little bit different than what we've been used to using for on-premise firewalls. So what does this look like when we start automating this build and devs now can spin up environments? This is kind of what it looks like. I've got an application being deployed and I'm in one availability zone. I go ahead and scale it horizontally. So now I have a security group. That's the red box around it. And now I have an application that's scaled across availability zones. It's in a shared security group so they can talk to each other. And I've got a master and slave database now that are actually in 2 different availability zones. So I've got a highly available application now that actually meets the SLA requirements for Amazon. If they have availability zone go down, the region is still up, your application will still be up. But I now start deploying this application over and over and over. So what happens? You start to run more security groups, more ACLs. You're compounding a complex. The complexity isn't necessarily the technology. The complexity is your process, your desired goal being applied consistently across the environment. And so you end up with a whole bunch of security groups. The reality is you do start to hit things called soft limits and hard limits. A VPC can have, soft limit of 500. Security groups, you can only have so many ACLs, you can only attach so many security groups to so many NICs. These things are adjustable. You can call Amazon and change the soft limits and increase them. But these are things that you're going to have to do. So we want to talk a little bit about, in this scenario, I'm creating a different security group for every single one as it scaled out. What happens if I want to start doing the best practices of how I consume this at scale. So there's a couple concepts that are different in AWS networking. Typically, you go from broad VPCs and start to come down to shared VPCs. In this drawing, I'm kind of actually doing it wrong on purpose. I have a lot of security groups being fired up with micro-segmentation for every single application. I'm very quickly going to hit soft limits this way. If I had 5 developers deploying the same thing 15 times, start multiplying it out, you start to see how you start to hit these limits. So we have kind of ways where we can do some different things. So let's jump over to another demo here for network segmentation. I'm sorry, I got completely ahead of myself, guys, with the demos. I didn't show you the image creation. I just jumped to my next video is actually showing that. Excuse me, this jumping back and forth messed me up. Let me step back real quick and do the image stuff. So I showed you the Jenkins process of building, deploying, but how did I actually build the images so that the developer always had the correct image? Okay, so we're in the product again, and so what we're using here is actually a Packer. What's different here is Packer a lot of times is command line. Packer is also called via scripts. What we're doing here is turning it into a catalog entry that can be consumed over and over. I now have an application profile that really is calling the Packer process. I want to create an Ubuntu image here. Where do I want to create it? I want to create this for Amazon US East. The process is now kind of kicking off, and you see that a job is now running, and this is the service being called for Packer. We're going to jump ahead in this video a little bit. This whole process is 27 minutes, so I'm kind of going to jump ahead in sequences here. So now we can kind of come in while it's building. Let me show you what the service looks like. So Packer itself is normally a tool that you run. We've turned it into that Lego block. And so we come in here, and we have the actual service name. We have things like we can apply costs per hour to services. I have an external process being called here that's this external action. This is where I'm calling Packer. And then the service is starting. We have this parameter of an image name that's being collected, what you want to call it, etc. So let's jump ahead another 7 minutes into the process and show you kind of what that looks like as it kind of runs. Okay, so now in the log here in the bottom right corner, we say installing Packer. The developer is actually seeing, without knowing how Packer works, or the IT guy who doesn't know how this image generation process is happening, he sees that Packer's being installed, the plugin's running, etc., and the process is kicking off. Okay, so let's jump ahead a little bit more. We're going to jump another 9 minutes ahead into the process. The Packer process has started running. I'm going to jump to 18 minutes here. This is what a Packer looks like, so in case any of you haven't seen it, this is what was called by that service start. The catalog just made it simple and consumable. This is actually what was called. There's really no hard coding in here. A lot of the things like which Amazon region was it, that's being substituted into the script, and this is what's being called. So now you start to see what's occurring in the console is I don't have my Packer image built yet. We're refreshing it a little bit. We're going to jump a few more minutes ahead to 26 minutes. And some of what I want to show you guys, why I'm dragging this in the video, is like this really does take time. You know, this is something that a lot of times takes many, many days for your IT organization. But now I've automated it. The whole process, this is running 27 minutes end to end in the video. So this is the whole start to finish with my guy refreshing it. So now you see in the very top, Ubuntu 16.04. So now I have a new Ubuntu. I went from Ubuntu 14 to Ubuntu 16. It's pending, it's building. Go ahead and play on it again. And so what's going to occur here now is the build process is finishing. What's unique here, and so this is where it kind of ties back in. So how do I tie this back into the profile? Well, we have API calls. How do I actually map the logical image reference of Ubuntu 16.04 to each image reference in all the various clouds? We have APIs for that. So this Packer process is finally coming in. It's going to complete here. You're going to see it in just a second. Say that it's completed. So creating new image mapping. So now what's happening is we're actually calling our own APIs, kind of looping back into ourselves from the process. And in the cloud, the Amazon US East, I now have an Ubuntu 16.04 that's been created. I go into my cloud mappings, and now I have an image that was just rebuilt for Amazon US East. So this 27-minute process, if I had every single Amazon region in use, you could just call this 15 times. You want to use 15 regions? Call this 15 times for each region, and now what's happened is Ubuntu 16.04 is being rebuilt every month. The API calls are being called to remap it into the platform. Now every single application profile that says I want to consume Ubuntu 16.04 is doing so. So sorry for the confusion there, for skipping that one. Let's jump to the next one now. All right. So I mentioned one of the problems we have is that drawing of network segmentation. I ended up with something that was going to have a lot of microsegmentation, not actually sharing. So when you're sharing isolation tags, this is another quick example. We're actually using APIs to do this. So I'm giving you various flavors for some of you. This is instead using Postman, a JSON product. This is calling us to deploy it, but what's happening here is we're actually coming in and saying, I want to deploy 3 CentOS boxes. But instead of them being all isolated and microsegmented like you saw on the PowerPoint, what's occurring here is I'm going to deploy all 3 of these, and they're actually going to share one security group. So that broad to more specific, but not overdoing it where I just artificially overrun the environment. So now what we've launched, this is the Amazon EC2 console. I've launched 3 instances. And you'll notice what's happened here in the bottom right corner, clicker, deploy, isolation group, AWS reInvent 2. All 3 of these images, instead of having each one discrete. And this is what happens for you. If you go into the EC2 console directly and just deploy an EC2 instance, a lot of times a new security group is created. So this problem isn't just our product, for example. A lot of times that's what's occurring in your devs. If they're not as AWS familiar, they may be just going asking for instances and doing one of 2 things that are bad, using the default, which is basically everything's allowed, all incoming, or they're creating unique security groups for every single one, and then they're running into, why can't I create any more? They start to hit those soft limits. So these are kind of real operations use cases and examples. And so this is going to kind of go through, these CentOS VMs were deployed, they're in a shared security group, the firewall rules were programmed based on what was in the application profile, and at the end we're actually going to be able to SSH, and they can actually get into each other. So we're actually sharing across the security group and not just creating these isolated islands, so to speak. So it kind of comes on in. You guys have seen SSH. It's not very exciting, but it's a good, quick way to show it. Each one of these kind of comes up, SSHs into the other, and make sure that it works. New key. Exits. It's good. All right, so let's go back. Move on to the next. All right. So how do you automatically scale across? I mentioned you need to consume availability zones for your SLA, but I also want to automatically scale because of application performance. Now, Amazon has great features of scaling. That's become a good thing they could do. But how do I have the same functionality of auto scaling in my on-premise environment and what I can consume in AWS regions? So from a product perspective, that's what Cloud Center is offering. So let's jump over and show you that. Okay. So same kind of thing you've seen here. These are policies. So I'm going to come into the product and I'm going to create a scaling policy. Very simply, not creatively named scale policy. This scaling policy is basically CPU utilization. I want to scale out when my CPU is greater than 60. I want to scale in when it's less than 40. Those aren't very great, but there's other things you can scale on as well. CPU, memory, disk read-write rates, et cetera. So these are technical kind of metrics. You know, it's fair to say you can also scale on business metrics. You may have an application performance management tool that needs to scale because you know if you get 50 people in the shopping cart, you need another web server. This is very common. What's the product that you can make those API calls for and scale? So, you know, you can do that with Amazon APIs, you can do that with Cloud Center APIs, et cetera. So we're going to move on quickly. So we have this application profile now that based on the governance tags. So this is actually showing what a deployment looks like. I showed you Jenkins. This is actually deploying it not via APIs. Like the second demo, this is deploying it in the actual UI. So I've come in and said I want a scaling demo of a WordPress application. I've gone through and said what tag I want. Here's my different tiers in the application. I now see what clouds are available and regions are available to me. I see the cloud account that I could use. I could have multiple cloud accounts here. And now I get to start to pick my things. What instance type do I want? What's my price for deploying that MySQL? I want that to be a medium. It's 52 cents an hour, 5.2 cents an hour. I want my Apaches to be a medium as well. They're 15.6 cents an hour. In my profile, I have things like I have 2 extra volumes I can create. How big do you want them? Do you want those to be SSD or some other disk and media type? Things have already been selected as well based on the governance tags. Which VPC is dev? Which subnets are available? These are all loaded because of the governance of the platform, etc. So what we're going to do now is this is going to deploy the 3-tier application, load balancers, Apache nodes, backend SQL database. In this case, it's MySQL. All right, so this is the status that someone would see if they were in the product. You know, we're deploying the nodes. This is time accelerated a bit, so you see everything went from yellow to green really quick. I now have on my Apache tier 3 nodes. And this is, you see those, that was in D, East 1D. This is an East 1B. and this is an East 1C. So one of the things we do, I showed the diagram of where we were adding nodes across availability zones. When we add a minimum number of nodes, this profile said I want a minimum of 3. We deployed 3 and actually round-robined them already across the availability zone. So the deployment already followed the best practice that gives you the SLA availability of the region. Now on the back end, what's occurring here is we had that, I need to generate load on the application, so we're going to come in, set up WordPress real quick. This could be automated as well. So now we have a WordPress application that's up and running. We have JMeter or some other application benchmark now pounding on the system, or these are real users. So now what's happened in this? I had 3 nodes. You'll now notice I have 5. I see running, and up 3 I have starting. The system now has realized there's a load that met the scaling policy, and it's now adding additional nodes. And again, it's going to round robin them across the availability zones. And that's what's going to show you here. That one's in 1D. The next one's up and running, it's in 1C, and this one's in 1B. So the system will continue to round robin them across the availability zones or fault domains in the system. You may have on-premise environments that have the same concept of fault domains, availability zone equivalents, and so the same thing's going to happen. So the benefit here is that the same kind of benefit you want to have in Amazon regions, you can also have in your on-premise environments. Still one profile that lets you kind of deploy it everywhere. All right, so we're going to jump over here. Screen went too far. Now, how many of you guys are actually already using things like Amazon RDS, Amazon ELB, the services besides EC2? Okay, good number. What's usually hard for an organization is you're familiar with MySQL, Microsoft SQL, Oracle, et cetera. You may already be using MySQL in-house. That makes it really easy. Amazon RDS can create a MySQL version of it. So all you're doing is picking up your application and moving it, and now you have this pay-as-you-go, well-managed, well-deployed RDS service that is still based on MySQL backend. So your application's compatible. But do your developers know how to do the APIs for RDS? Sometimes the adoption of moving from on-premise environment to Amazon is, how do I transform my applications? And so in the environments where the developer is responsible for that, they have to go learn, how do I call RDS? How do I set up the security groups and availability zones and spread it around? And so what's happening by having this model-based approach, we can have the complexities of the service itself, in this case RDS and AOB, as drag and drop Lego blocks. And the developer just focuses on, I'm moving my MySQL schema from a local MySQL open source platform to an RDS that also accepts MySQL. So let's flip over real quick. And we're good. Okay, so same kind of catalog of services. I have a WordPress application. We're going to open it up in editor mode, someone who can edit it. And you're going to see that I have dragged and dropped, instead of the previous where I had HA proxy and MySQL as my Lego blocks that built that WordPress application. I now have drug out Amazon ELB. The service was here. It was just, I drug it over onto the topology, drug a wire to it. The best practices of how deployed ELB were already in the platform. No one in your organization had to learn how to use ELB other than dragging and wiring it. Same thing, the RDS MySQL version was drug out and wired together. So, same application, WordPress, but now we're consuming the actual platform services of Amazon. Same kind of deployment environment here. I come through, I give it my unique instance name, I give it my dev tag that tells it which, the governance model of which environments. I see that I can use Amazon one region. I then see things like subnets and VPCs, and now it deploys. Same kind of magic of time scale. We just went out, I think this one actually took about 20 minutes. So whereas I think the WordPress one you saw before took like 8 on premise, this one took about 20 minutes going out to an Amazon region and deploying everything. All right. So the consumption of these platform services, and this isn't just necessarily for Amazon services. I mean, there's a lot of, Amazon is developing new services all the time. So you heard about something great at the show here. You have one guy who really gets spun up to be an expert on it. He can model it as a service. He can create the Lego block for this new Amazon service. One of the great things about Amazon, they're innovating regularly. They're always coming out with new services. How do you get the application developers access to those services? Because a lot of times what happens in the DevOps process, that same financial services customer I mentioned that had the 127 steps, they actually, one of the reasons they were trying to get the process automated is they wanted to rebuild their application portfolio. They had a legacy, not cloud-ready or cloud-native application portfolio, relied heavily on a central database. They wanted to start using things like Cassandra, Mongo, NoSQLs, load balancers, scale-out architectures, microservices, containers. And so part of that process is giving the developers approved financial, regulatory stacks that they can actually learn how to use new languages, new processes, new things. Do you want your developers necessarily figuring out how to run Cassandra clusters or MongoDB? The Lego block already is there for them to use it. If the new Amazon service comes out, one person models the service. Maybe someone out on the internet already figured it out. Cisco, we're building a lot of these services and posting them out on a communities.cisco.com site. In the next couple months, that'll be open for Cloud Center. And you'll actually be able to find someone else who already figured out some new service that just came out. You just import it in as a Lego block, and now you have the drag and drop capability. So it's not just consuming the existing Amazon services that you may be struggling to adopt. It could also be the new services as they come out. It could also be your services, your load balancers. Maybe you have a certain way you build Nginx or you build Tomcat that's hardened and optimized for your application. One person does it, tests it, makes sure it works the way they want it. Everyone gets the amplified correct behavior. And so again, automation amplifies behaviors, bad ones and good ones. And so in this, we're giving you the ability to have the amplified good behaviors there. So one last quick thing. This one's actually going to go live product. I mentioned model once, deploy anywhere. Right before the demo started, I actually kicked off a benchmark job. And so because we can deploy the application once, model once and deploy anywhere, I've set this up to deploy to 2 Amazon regions. Probably the least expensive and the most expensive. Anyone know who the most expensive one is? Usually GovCloud, yes, actually, but Tokyo is slightly more expensive on most things. But yes, GovCloud in most cases is, but Tokyo actually, they go back and forth. So in this case, we're using Tokyo because it's easier. GovCloud is also, you get a brownie point for GovCloud. So in this case, I've done 3 instance types, sizes, in 2 different Amazon regions, East and Tokyo. And what you're seeing now is the benchmark is actually measuring transactions per second against the application. So we have JMeter here. This is a Sugar CRM application that's deployed. And we have a JMeter test bench that's actually exercising the Sugar CRM website. And what comes back on the graph is, where's my cheapest, where's my fastest? So now the deployment scenario changes a little bit. Instead of going through that pick your instance, pick your tags, pick your size manually, where is it the cheapest? Where is it the fastest? Where do I get the best performance value blend? This is what we offer in a different kind of deployment experience when an application has been benchmarked. And this is kind of you're seeing the chart of, in this case, in the top right, it says best price performance is US East, C3 large. Best price is US East, M1 medium. So as you actually deploy applications across your on-premise environments as well, you may find that some of your applications do run best. And you may have a private environment that actually is optimized and finely tuned for your specific application. This is kind of the proof of certain things run better in certain environments. I think you're going to see, it's interesting, you see the dots kind of even. You're seeing that US East and Tokyo actually perform pretty much exactly the same for each type of instance size. All that's happening in the spread horizontally is that one region's more expensive than the other. So kudos to Amazon that actually pretty much you get a consistent performance. M1 medium performs pretty much the same in all regions, and this is the empirical data to prove it. So I'm going to stop there. That's kind of the end of what I had. Hopefully that was helpful. We have about 12 minutes for questions, so don't be shy. Questions? Thank you.